Welcome. In this video, I'm going to walk through theoretical and then percent yield calculations. So I would encourage you to have your assignment pulled up on your iPad because it's going to be somewhat hard to see the writing up here. I chose orange. It's kind of silly of me, so I'm sorry about that. I'm doing number one on your practice. So scoot this up a little bit so you can see a little bit better. Okay, so I've got my equation up top. I went ahead and balanced it. There should be a 2 in front of the NH3 and then a 2 in front of the KCl. I know we can't really see that because I've moved everything so that we can see better, but that took care of my balancing. So letter A is done. Now what I've got set up is my given and then my need over there. For theoretical yield, I want to remind you of the limiting introduction assignment that you did. And maybe you'll think about the ham and cheese sandwich example. It doesn't matter which thing you run out of first. Whenever you run out of something, you're done making sandwiches. That same logic is going to apply here. So what we're going to do is we're going to say, okay, if I turn all of this NH3 into KCl, how much can I make? Well, then if I turn all of this into moles of KCl, how much of that can I make? And then whichever number is lower, that's our theoretical yield. That's how much we can make theoretically if everything goes as we think it should. So for now, we're going to go to moles. There will be times that we'll have to take that extra step to get to grams, but today we can just go to moles because the last step of moles to grams, once we're into moles of KCl, we would do the same step to get from moles of KCl to grams of KCl. So it doesn't really matter. So I also wrote, I don't know if you can see that, but I wrote our molar masses up here. I pulled those from the periodic table, and that's what we'll use to convert from grams of this to moles of this. If you're not using your molar roadmap, you probably should be. So I need grams NH3 on the bottom, and I'm going to go to moles NH3. I know I have to do that because I'm trying to get to moles of something else. The only way to get to moles of something else is to go through moles of this thing. Okay, so my next conversion bar here, I want moles NH3 to go away. So I put it on the bottom, and I'm trying to get to moles of KCl. Now when I have moles over moles, I go to the balanced equation to get my conversion factors. I have a 2 here, and I have a 2 here. So mathematically, that's not really going to affect anything. So I'll take 34.5 divided by 17, and that'll be my answer. So that is 2.03 moles KCl. And again, that tells me if I use all of that NH3, I can make 2.03 moles of KCl. So if we take that back to our sandwiches, I can make 2.03 sandwiches. I'm going to do the same step here, but now I'm starting with that potassium. Oh, that's a 2, not an E. Start with the other molecule. And my molar mass there was 415.09. That's a pretty big molar mass. I'm still going to moles of KCl, so that'll still be on top of the last conversion bar. And now I'm trying to get out of moles of that K2PTCl. Remember, I pull my numbers, moles over moles, I go to the balanced equation for that. Okay, so that tells me I have enough of this stuff to make 9.02 moles of KCl. But again, the lower value, whatever the lowest number is, that's my theoretical yield. Now we've got some stuff left over. We've got some of this stuff left in the container. We could figure out how much is in excess. We'll leave that for another day. So the last step is to figure out how many, what our percent yield is. Okay, so here in this problem, it tells me that I've got 74.6, nope, 76.4, I mixed those up. Our actual, so when we did the reaction, we dumped it together, and what we actually got out of that was 76.4 grams of KCl. Sorry, I'm reading from the assignment on my screen as well. Okay, so my theoretical yield was in moles. My actual yield is in grams. So I'm going to do one more step there. Bump this down just a little. So I've got 2.03 moles KCl. And I need to figure out how many grams that's going to be. 1 mole of KCl. Grab my periodic table. Potassium is 39.1. Chlorine is 35.45. Sure wish I could do that in my head. .55 grams of KCl. So I need to multiply that by 2.03. And that tells me I got 151.34 grams of potassium chloride out. Oh goodness. And that, again, that was my theoretical. So our last step here, I guess I'll write it right here, is to calculate our percent yield. So that equation is A over T times 100%. So my actual was 76.4 grams. My theoretical was 151.34 grams. So that tells me I only got 50.48% of what I thought I would get. So this is my percent yield. The 2.03 was my theoretical, or this could be my theoretical depending on which unit I want, right? It could be the grams, it could be the moles up here. Last but not least, this calculation also gave us one more piece of information. Since this is the thing that produced the theoretical yield, it's called the limiting reactant. It's the reactant that limits how much product can be made. Again, go back to the silly examples we did in the intro. The thing that determined how many sandwiches we could make was the limiting ingredient. This is the limiting ingredient for making KCl. Got some of those for you guys to practice. I should be right across the hall. If you guys need me, please let me know. Come see me during SST if you have any issues. Lean on that molar roadmap, and you guys got this.